Okay, so in this particular example, we are going to compare our standard deviation. And instead of just looking at things on a number line and thinking about how far spread out we are, we're actually going to go through and calculate our standard deviation for both of these and then go from there. Okay, so we have two data sets. Each of our data sets have 6 values, and then I've set up tables for each of these data sets with our 3 columns that are mentioned in the instructions on the previous page. Our data, the second column is data minus mean, and then the last column is data minus mean squared. All right, so let's work through this first set here. So both of these sets have a mean of 9.5. So we're going to take our data minus our mean. So 5 minus 9.5 gives us negative 4.5. 8 minus 9.5 gives us negative 1.5. 9 minus 9.5 gives us negative 0.5. All right, so notice that these values were below our mean and we get a negative number for our difference here. 10 minus 9.5 is going to give us a positive 0.5. 12 minus 9.5 is going to give us a 2.5. And then 13 minus 9.5 is going to give us 3.5. So we found all of our deviations, right? These differences are our deviations. Now we're going to take these and we're going to square these. We're going to think about these as being in parentheses. Right? So what that means is when we square negative numbers, remember negative times negative turns positive. So negative 4.5 squared gives us a positive 20.25. A negative 1.5 squared gives us a positive 2.25. Our negative 0.5 squared gives us a positive 0.25, so they all turn positive. We do a positive 0.5 squared. It also gives us a positive 0.25. 2.5 squared gives us 6.25, and 3.5 squared gives us 12.25. So we filled out this third column here. Now that we have this third column filled out, we're going to take all of these values that we have here. Again, they should all be positive. So we're going to add up our 20.25, 2.25, 0.25, 0.25, 6.25, 12.25, and that gives us a sum of 41.5. So the first thing we do, we find our mean. In this case, we could have found it or it was given to us. And then we go through and we fill out our table. Right, now that we have our table filled out, we are going to use our standard deviation formula. So our standard deviation formula, S equals our square root, sigma x minus x bar squared over n minus 1. So in our square root here, right, this summation that we just found, this 41.5, is our number that goes up top. And then in the bottom, n minus 1, well, our sample size had 6 values, so we're going to take 6 minus 1. This is going to give us the square root of 41.5 divided by 5. This actually divides evenly. If it doesn't divide evenly, I recommend at this point putting this into your calculator, but this one actually does divide evenly. So 41.5 divided by 5 gives us 8.3. So we're going to type the square root of 8.3 into our calculator, and we get 2.881. Make sure you're rounding carefully. Make sure as you're going through these, if you do rounding, try to wait until the very, very last step to do so. And then round to the appropriate number of decimal values. A lot of times we use either 2 or 3 decimal values for standard deviation. Okay. So our standard deviation for data set A is 2.881. Now we're going to go through the exact same process for data set B. All right, so here are our data values. Our mean in this case is also 9.5. So 8 minus 9.5 is negative 1.5. 9 minus 9.5 is negative 0.5. 9 minus 9.5 is negative 0.5. 10 minus 9.5 is positive 0.5. 10 minus 9.5 is positive 0.5. 11 minus 9.5 is positive 1.5. Yeah. So again, our middle column could be positive or negative depending on our values. Now we're going to square all of these. Negative 1.5 squared is 2.25. Negative 0.5 squared is 0.25. Negative 0.5 squared is 0.25. Positive 0.5 squared is also 0.25. Positive 0.5 squared is still 0.25. Positive 1.5 squared is 2.25. Right, so again, our last column, remember that after we square these, all of these values should be positive. And then we're going to add up all of these values, and we get a sum of 5.5, right, which is significantly smaller than our sum in this particular data set. So our standard deviation, again, we're going to take sigma x minus x bar squared divided by n minus 1. Right. So our sum in this case is that 5.5 that we just found. We're going to divide that by our sample size minus 1, so 6 minus 1. This gives us the square root of 5.5 divided by 5. Again, this works out evenly to give us 1.1. If it didn't, I wouldn't recommend doing a bunch of rounding here. Just type this whole thing into your calculator, and this gives us a standard deviation of 1.049. So as we expected, based on looking at our number line, this data was more spread out. We have a larger standard deviation. This data was less spread out. We have a much smaller standard deviation. So our numerical values that we get here support our conclusion that we came up with previously.